However, are there word problems? Yeah. However, even though there are word problems, if we can talk about how to translate those word problems, maybe they'll be a little bit easier, huh? Now, on this page, all we've talked about so far is function of, what comes before and what comes after. So we're going to start not worrying about the huge old paragraph that we see, but start looking for function of or something similar that could tell us which quantity is supposed to be the y and which quantity is supposed to be the x. But before that, if this is a homework problem, what might have some of you guys, not just because it's words, but what might put you in a bad attitude because of maybe something that I require for my class and for homework?
Write it down.
You're like, no. Does anybody remember what I said about word problems? You don't have to write the entire thing out. But what do you need to put? The directions, which are probably just something like solve. And the given information. Now you're like, well, the whole paragraph is the given information. If you want to write it, go ahead. But how can we, let's focus on it. Thank you. How can we take this paragraph before the A and the B and summarize what's been given?
The ratio of the height to the radius is 4.
That's important, right? I'm going to just star that one really quickly. The ratio of the height to the radius is 4. Anything else? Let's just do this. Something like iced tea can problem. So iced tea can. You're like, okay, it's the one with iced tea. They're trying to make a can, whatever. You might even want to put in something about slightly narrower and taller than a standard can. Think Arizona tea, how it's a little bit taller and skinnier than like a, is it skinnier? No. Oh, well, it's just taller. Either way, an iced tea can, you could put this down, but if you think about it, are they giving you any sort of measurements as to that slightly narrower and taller? Not really. They're giving you this mathematical clue here below, so you don't even really need to write the whole slightly narrower and taller. How could we translate into math the ratio of the height to the radius is 4? We have to put a given, and that is seemingly the most important given of this whole paragraph. The ratio of the height to the radius is 4. To be honest, h equals 4r is a true statement. I'm not sure if that's directly translating this sentence, though. H equals 4r is right. But who can tell me exactly what this statement is saying? Ratio. Oh, we talked about that in Algebra 1. I think we talked about it in Algebra 2. How do you write ratios? You have quantity, T-O, quantity, quantity to quantity. You have quantity colon quantity. I know because I taught your Algebra 1 book back in the day. But then you also have quantity over quantity. Oh, that sounds like a nice little equation if it's a fraction. Who would go on top? Now, why did I say h equals 4r is true? Because it is true. Move the r over, and that's true. But that's not technically what the statement says. The statement says ratio fraction of height to radius, h over r, is equals 4. Does the translation kind of make sense? Okay, a little bit. That's all we're going for right now. Letter A. All right. Letter A. Write the volume of the can as a function of the radius r. So who's going to be my y? Think about what we wrote yesterday. Write the volume of the can. This is literally all you had to write for the whole big paragraph. Just make sure you carefully translate, okay? Volume as a function of radius. Who's the one? Because yesterday, what went before the wording function of? The independent or the dependent? The independent came after. The dependent came before. So y is, in this one, volume is going to be like r, y, and radius is going to be like r, x. Okay, how about the next one, letter B? Volume is like r. dependent, so it'd be similar to, careful, y. And who's our independent or our function of this time? No. Here's the struggle. Anywhere in that paragraph up above the problem, the A and the B. Did they tell us anything about volume of a can? Gosh, why wouldn't they tell us that? Because we took geometry and they assume that we remember stuff. Now, do we all remember stuff perfectly? No. But don't worry, our book knows we don't remember stuff perfectly. Is there anywhere in our book that has maybe some review formulas? There's some right there. It's all the functions that we're going to be learning. However, do you guys look in the back? Oh my goodness, where's the can? There it is, right circular cylinder. See? Now, is this perfectly the can? My ones that are more realistic than others. Is this perfectly the can? No. What's a little bit off? You have the little lip right here where it's tilted. First of all, you have nothing up above. Second of all, it's tilted in. And third of all, doesn't this go up a little bit? So we're approximating. Okay? We're approximating. For the number of fluid ounces, they would have to figure that out more precisely, but maybe they don't even worry about taking the volume of that, but they pour it in something else and take the volume of that. That'd be smarter. But either way, what's the volume formula of a right circular cylinder? Pi r squared h. Area of the base times the height. So kind of an additional formula that we needed to know or look or find out. V does equal pi r squared h. Now some of you are like, well, this is dumb. It says write the volume formula. There's the volume formula. But what is wrong with writing that down for letter A? Who does not belong?
H.
H doesn't belong. Why is pi okay? It's a number, not a variable. He's fine. He's a number. He's a constant. 3.1415926, etc. However, if it says as a function of radius, it only wants radius. So that's why some people were right when they said H doesn't belong. So here's our question. Here's our problem. How do we get rid of H without just destroying him, but then also messing up our entire formula?
Get rid of it.
How? You can't just take something out. Math. The only way we can get it out is if we substitute in. We could divide, but H is still there. But what can I plug in? Did you forget so soon our clue? There he is. He was hiding, right? I know, it's goofy, but it's a way of remembering. They gave you information, you just had to go remember in your handy dandy notebook. There's your clue, right? H over R is 4. How does that help me get rid of H and keep only in terms of R's? What could I say H equals?
4R.
So then mathematically, how can I finish this problem? Plug it in, plug it in. Plug it in, plug it in. Isn't it Laden? No, Reese is like this. Now hold on, wait a minute. How did R get cubed? He got plugged in and then times R squared. Why is the 4 in front? Because he's a number. We always put the coefficients in front. Dun, 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 dun. Why? Volume as a function of radius. The pi is allowed. He's a number. We're done. Now you guys go ahead and try letter B. This time they say only as a function of height. H is allowed to stay. R has to get out of there legally through a substitution. Ready, set, go. You have about a minute. Focus. B. No.
smelling drugs.
Can we focus at the problem at hand?
The problem is,
Jason, you get your whole group in. Start in the same place because it's still volume of a right circular cylinder. What do you guys put as your important piece of information that you would have to plug in? H over 4, right? Wait. How do we get R alone? You could do it from up there, but isn't it easier when you have it like this and then just divide the 4? Right? Okay. Now the plugging in, I'm not going to do quite as quickly just because this is a little bit harder, but we get V is equal to pi H over 4 squared H. Help me out. We got to simplify this thing just to make it look nice and concise and neat. How do you square a fraction? Square both, top and the bottom. So, we end up with V equals, we still have the pi. We have H squared all over 16 times H. Why am I putting over 1 for some people? It's just going to help them connect the dots. To think multiply numerators, multiply denominators. Yeah? Technically, what could I do with the pi too if I wanted to? Over 1, I guess. Let's see if this makes sense though. 16 and pi. We could do pi over 16. That's kind of ugly though. It's a little bit nicer to have the 16, which is in a denominator, hence why 1 over 16. Think about there's a 1 in front of the h squared and a 16 in the bottom. Then pi, then h to the power of
3.
Think about it. There's a 1 next to the h squared. There's a 16 in the bottom. Take those coefficients away, 1 over 16. You can kind of put that out in front of the pi, and it's a little bit nicer. We could also put pi over 16 h cubed. It'd be the exact same. Now, we just spent an awful lot of time, but as you guys said yesterday, it was probably on your least favorite way of talking about math, right? Now, hold on real quick. Are there any other words that could come up in a word problem that would have an English meaning, but also a mathematical symbol that might and sometimes means, depending, and could be like addition or multiplication, or, oh, that one's a hard one. Of could be function of, so f of x. I guess we could say actually like write out squared or cubed or things like that. What if you saw something like difference? Subtraction. How about sum? Addition. How about product? Multiplication. How about factor? Factors of? Factors are actually multiplication also. How about quotient? Division. So there's some other words that might come up, but they're ones that I know you've seen before. This was, I don't know, kind of complicated to think through all the different steps. So we did one example, but there is some simpler, I don't know, more mathematical things we need to talk about. You might have a few word problems. And to be honest, guys, remember, it's just a way of dealing with math, verbally, algebraically, graphically, numerically, so you're going to see some word problems in maybe all of the homeworks, or some of the homeworks, or most of the homeworks. It's not just a this section sort of thing. We just kind of got to talk about it this section. Now, going back to some types of problems we need to talk about. Domain. Domain is a set of all possible f values for a function. Okay, you've memorized that for at least 2, if not 3 years now. There are technically 2 different ways of talking about a domain. Either a given domain, it's given to you, and I'll give you an example. Just given to you by the book, by the problem, by me. Or implied, and that's the hard one. Given or implied? So given that's a given domain. Why is it given? It's written. Yeah, it's literally right there. They say only for x's between 1 and 5. Including 1, including 5. How many x's is that? What about the uncountable infinities in there? What am I talking about? 1.1, 2.33333, 4.7698. I don't even know. I'm making that stuff. There are infinitely many numbers, but it only still goes between two endpoints, 1 and 5, right? The set of all possible x values, all the numbers in between 1 and 5. Infinitely many, but still contained. Given, stated, it's right there. Implied, is you just have a function y equals x plus 1 and you have to find the domain and you're like, but they didn't tell me. True, but if you know the function x plus 1, what it looks like, what happens when you plug numbers into it, maybe you can figure out what x's are legal, are allowed, are implied based on the nature of the linear function. Give me an x you can plug in that would get out a real number.
2.
Give me another one. Give me another one. Give me another one. Give me another one.
997.
There are a lot of x's going on. How about negatives? Can you plug in -5, still have a real number? Based on the nature of the function, all you have to do is add 1. As long as you plug in any real number, all real numbers are legal, are allowed. So if you have to look at this and figure out what's implied, one way is to say, hey, I can put anything in there and it gets out a real number. Hence, x is the set of all real numbers. Oh, that's gross. How long did it take to write all that? Took a while. Last year in Algebra 2, I think you did this funny thing with like braces and straight up and down lines and all this jazz. Here's a shorter way. You could do x. Well, sorry, what's the d colon for? Domain. X. Ooh. That's fun. Oh, so is that. Doesn't that look shorter than that one? Now, what does it mean? Domain is x as an element of or within the set of, little double r means all real numbers. In math, all real numbers is a pretty important thing, comes up a lot in proofs, etc. So we made this little symbol, not we as in me, but as people much smarter than me. Like the paragraph symbol in grammar, kind of, but it's like an R standing for all real numbers. Double lines. Could you still say all real numbers? Yes. Could you use the little nifty bracy thing from last year if you want to go back in your notes and review? Sure. I don't know. But does every function have all real numbers for domain? Let's talk about some where there could be some problems. A lot of functions have a domain of all real numbers. A lot. Every stinking line except for a vertical one. Think about it. Every single parabola, as long as it's an up and down facing one. Think about it. But there are some functions, and I promise you, memorizing this page is going to help for your future in math. There are a few functions that have restricted domains that are just implied based on the nature of the function. And the more familiar you get with these functions and with how they behave, with their nature, the more easily you'll be able to figure out the implied domain. Kind of like friends, right? The more you get to know them, the more you kind of figure out what they're saying, even if they're not really saying it, right? And some people are just obviously, like, you can read them like a book no matter what. But for most people, you kind of have to get to know them before you can really tell what they're saying, especially with implications and stuff like that. Same thing with functions. We have to get to know them so that we can figure out what's going on. So the first one that can have some problems with domain at least is if I was to give you something like y is equal to the square root of, I'm not going to put x, I'm going to put u, and you'll see why in just a second. Y is equal to the square root of u. And technically, what I'm about to show you is true for any root as long as the index, remember that's a spiffy little number that's in the root, is even. Now if there's no index, what's it implied to be?
1 square root 2.
Square root 2. But then every other root has to be there. Like a cubed root has to have a 3 up there, or a fourth root has to have a 4 up there, etc. So any even root, any odd root doesn't matter. It's going to be all real numbers. But any even root, there are some problems. Let me make myself a little more. I can get my end. Thank you. How do you find the domain? Remember, D colon, I'm telling you how to find it. You set u greater than or equal to 0, solve for x. I'm going to go ahead and throw an example up while you guys are writing that clue. But you set u greater than or equal to 0, solve for x. Example. I'm going to go ahead and do, what if y equals the square root of 1 minus x? Ricky, go ahead.
Wouldn't we solve for u instead of x in that example? No?
Just wait and see why I'm using u. Okay, hold on. If you guys look at this example, what is under the square root? 1 minus x, which I would call u. In math, as you go higher, we kind of start using certain letters, and even last year composition of functions, we could set the 1 minus x as g of x, and the square root of x is f of x, and it's f of g. Ugh, takes too long. We'll talk about composition some other day. But I just like to use u, coming from a calculus teacher perspective, to say, hey, there's a bleh inside, and what's the bleh? 1 minus x. So if I want to figure out the domain, the implied domain, I take the 1 minus x, and I set it greater than or equal to 0. Can anybody explain real quick why with a square root, an even powered root, the argument, the inside, has to be greater than or equal to 0?
Because it's the negative number.
There are negative numbers, everybody. Negative numbers under a square root. What kind of numbers would those be? Imaginary. Some of you are a little begrudging in the answer, but you still got it good. Now, solve for x. Why, Ricky? Because domain is the set of all x's. I need to get x in one. Okay. Most of you would approach this problem probably differently than I would. I would add the x. But some of you are like, it's on the wrong side. What could you do instead? What could you do instead? You would do. Subtract the 1 is what a lot of people would do, and that's totally valid. Now you have negative x greater than or equal to negative 1. How do we solve? Divide by negative 1, or what else could you do? Multiply. It's the same thing. But either way, when you divide or multiply by a negative, they both turn out positive, but what happens to my inequality? That's my domain. I got x alone. All x's less than or equal to 1 is the domain for y equals square root of 1 minus x. How did I do it? I used my clue. Set the underneath or the argument greater than or equal to 0 and solve for x. Now, what's another type of function that's going to have some problems? Yep. What if I have y equals p of x over q of x? And you're like, ugh, you're using function notation. I know, I'm sorry. But whenever I have a function that's a fraction of other functions, their x is like in the top and or bottom, I need to be careful because the domain says set q of x not equal to 0. Here's the clue. solve for x. Set q of x, which is the denominator, not equal to 0, and then solve for x. So let's get an example up there. What if I was to give you something like y equals, let's do an ugly one. For some reason, as soon as there are x's on top and bottom, kids start to get confused. It's not with you guys necessarily, it's just easy to do. Where could a problem occur in this function as far as x is getting plugged in? Only on or in the denominator. Don't worry about the numerator, he's fine. No stress. Just look at that denominator. And the clue says, for the domain, take the denominator and set it. Now, we don't have lots of experience with not equals. We have equals all the time, or inequalities, yeah, they're gross, but we've done them before. But can we solve for x with a not equals the same way as we could with an equals? Yeah. So, move the 1 to the other side. The domain for this function would be x can't equal 1. Last year, once again, I'm sure you had some sort of nifty brace thing. He was called what? Set notation? Is that right? But for right now, x does not equal. Sorry, it looks like an F. I don't know how that happened. X is not equal 1. Now, technically, guys, hopefully you did write down. In general, when we're talking about domain problems and the types of functions we'll see this year, roots have a problem, denominators have a problem, and technically some trig, like tangent, cotangent, cosecant, secant, have vertical asymptotes, they have problems, and then logarithms, they have problems. But the nice thing is we don't have to worry about it because basically we're just not ready for them yet. So we're going to get to these problems later. We'll actually make it 3 and then 4. But for right now, we're just going to deal with these first 2. So we have clues, how to solve, and we have a couple examples of how to get domains. Now, that's domain. Domain, once again, is figuring out the set of all possible what values? X values. So then let's peek at these examples real quick. Pencils down. Don't even worry about writing. If you want to go back and write them in your notes to help you, you definitely can to get some space. We still have some time, so hold on. I just want you all tuned in. Find the domain of each function. Letter A. What? It's not even a function. Yeah, it is. Why is it a function? Are there any repeated x's with different y's? No, it's a function. But it's only a function comprised of how many points? Yeah. It's a function comprised of 5 points. All right, fine. Do we have to worry about the uncountable infinities in between everything? It's just those 5 points. So what is my domain? Yeah, it's literally just the x's that are there. Just showing you, sometimes domain can be a little weird. If you only have that many points, it's just the x's of the points and you're done. There are no other x values. There is no -2 and there is no 3. There is no 3.5 because they're not connected. Okay, letter B. He's more normal. All real numbers. Nope. What's his problem? Denominator. There's an x in the denominator, so what's my clue? Take that denominator. He's not able to be 0. So how do we finish it? Solve by subtracting the 5. Domain, x cannot equal set of all numbers such that x is not -5. Now some of you are still kind of stuck with, how is that a domain though? That just says what x is not allowed to be. Exactly. And in math, that's implying x can be anything else. Does that make sense? By saying what it's not, you're implying what it is. Let's skip letter C just for a second. Let's go to letter D. All real numbers. Oh no, it's a square root. So then what's my clue? How do I figure out domain with a square root? You can check it out. Greater than or equal to 0. Take that whole argument. I would call it U, but take the whole mess that's underneath. We're not done yet. What do we have to do? Solve for x, get x by itself. So yes, subtract the 4. Sorry, my orientation's off. And this one I would say divide just because you have the 3 as well. So divide by a -3, divide by a -3, but do not make a mistake because as soon as you have a negative and an inequality, you better flip that puppy. Got it. Okay? Now let's go back real quick. Letter C. Volume of a sphere. Volume of a sphere. I mean, it's a formula, right? Is there a denominator? No. Oh. Is there a square root? So domain is all real numbers. Usually, if that was just a 4/3 pi x cubed and it had nothing to do with volume or a sphere, you would be totally right. No denominator, no radical, no trig, no logarithm, all real numbers. What's the struggle with them specifically telling me that formula is for a sphere and R, I know, stands for radius? I can't have a negative volume, which means I can't have a negative radius. How do you have a... Yeah, in geometry you don't have negative radii, right? Is there anything else that R can't be? Why? Yeah, there's no radius, there's no sphere, right? So I'm going to say, implied in the nature of the problem, R is greater than 0. I'm just showing you sometimes in a word problem. Even though the function is great, mathematically, I can put any number into this 4/3 pi variable cubed. In context, I need to keep R greater than 0. Hey, context is important, another reminder. Okay, range. If domain is all the x's, range is all the y's. And here's the sad thing. Domain, even though it's kind of complicated, you have to look out for problems, look out for tricky functions, look out for word problems where things are restricted by nature of like the radius and the sphere. Range, theoretically, is just this one little baby page. It is actually way more complicated. And we're not even going to get very good at him until we can review all of our different types of functions, like the square root function, and the quadratic function, and the cubic function, and all of our trig functions. We're just not going to be good at him, and that's okay. Oh, that's why it's off. That's annoying. Even though range is just like set of all possible y's. Figure out all the possible x's, plug them all in, figure out all the possible y's. But the problem is, we just talked about even if the x's are in between 1 and 5, how many different x values technically would we have to plug in if we were to plug them all in? I'm not going to plug in infinitely many x's to find the range, are you? Probably not. So instead of starting with figure out the domain, plug in all the different possible domains, which is unrealistic, I say think about the graph. But the problem is, the best way most of you right now can think about a graph is to go to your calculator. And that's a struggle because that means that's a crutch. So we're going to have to wean you off that crutch. But for homework, since we're only in section 1.4, you're allowed to use that crutch. But please, please, please understand that we're going to get better at visualizing the graph without the calculator, okay? And there are still some functions I expect you guys should be able to do without the calculator. Now, real quick before we go on, because I'm going to do a few examples, and actually I can start writing them. Let's do our y equals x plus 1. Let's do y equals x squared. We'll just stop there. Let's do 2 examples. But first, does anybody have a way of remembering that range goes with y and domain goes with x?
DR. Alphabetical. I don't get it.
This D comes before R in the alphabet.
Oh, D comes before R, so X comes before Y. Yeah, that's one way. I just like, and I don't know, it's silly. I think I even heard it from my high school teacher a long time ago. If I taught it in Algebra 1, just think of rangey. Little baby rangey. So cute. Because range goes with Y, and then domain X sounds like a medicine. I don't know. Something silly, but for some reason, back in Algebra 1, it helped a lot of kids, last year's seniors. Remember, domain goes with X, domain X. I don't know, it's weird, it's like a medicine. And then rangey, a little bit of rangey. Okay, so anyway. I know it's dumb. You guys have dumb ways of remembering stuff too. Songs. That's not dumb. Poems, pictures, little acronyms. I don't know. Come back. Okay, y equals x plus 1. If it helps you learn, it's not dumb anymore, right? Okay. X plus 1, we just talked about him. He's a line, and he's a line that goes like this, sort of. If that's like 1. If that's my intercept. Question. Domain says set of all possible x values. If we were to look at a graph, and this will just kind of help us out generally, because if we have to look at a graph, well, we have to figure out how to read it. Graphically, with domain, we ask ourselves the question, how left to how right? What do I mean? X's move horizontally. So if I'm trying to figure out what x's are legal, does 0 map? Does -1, -2, -3, -10, -100, -1,000? They're all going to go to that line. Go to the right. How far right can I go? 1 goes, 2 goes, 10 goes, 100 goes, 1,000,000 goes. X is all real numbers. What would range answer? Domain, how left, how right? Elaine, focus on
How up and down.
how up and how down. And theoretically, if I'm thinking about inequalities, I'll probably say instead, how down, how up. Because remember when we state inequalities and whatnot, we start with the lower and go to the higher, so the negative to the positive, or the smaller positive to the bigger positive. So looking at the first graph, question, what would you guys say the range is for y equals x plus 1? How low does it go? How high does it go? So technically we'll say y is within all real numbers. That's my little e, sorry, it got kind of messed up. The range, y is within all real numbers. Everything's fine. Why did I choose x squared? Because you guys know him. He's easy, hopefully. Who is he? A parabola. Centered at 0, 0. Uh-oh. What's the domain? How far left? Forever. How far right? Forever. Domain is all real numbers, but what about range? How low does he go?
0.
Can he equal 0?
Yeah.
0, 0. 0 squared is 0. How high does he go? Infinity, so greater than or equal to 0. Now, using your calculators, using graphs is going to help, I hope, I pray, until we can get better at visualizing graphs ourselves. However, you still have to know how to read the graph. Domain, how left to how right. Range, how low to how high. Kind of makes sense? Let's keep going, though we have a couple other mathy things to do. You guys have them, sort of? Kind of, maybe? Function notation. Aw, man. This one's been stumping, I know, 1/4. That's what I took 2 days on it. 1/4, not 1/4. Function notation. Some of you guys have been struggling with since Algebra 1, and it's okay. There's a very real reason as to why you struggled with it. It's called, you were taught that parentheses mean multiplication, and all of a sudden someone threw this random notation at you and told you, wait, don't multiply. Right? That's what's going on. You learned parentheses meant multiply. 2 outside x, oh, it's 2x. But f outside x? What's going on with it? This one on the outside is called the name. You guys have seen more than just put a period. More than f. You've seen g, you've seen h. Probably not I, that's usually the imaginary number. Probably not e. A of x, that's kind of weird, but maybe. But you can name functions by letters. And why is that good? Because if you say y equals, y equals, y equals, y equals, that's a lot of y's, and who knows which is which. In your calculator, you could do y1, y2, y3. But most of you don't want to write y1, y2, y3. So we can call them f and g and h, etc. Notation, when we're looking at this, f is our function, x is our dependent variable, I'm just going to put bar. And the parentheses don't mean multiplication. They're still super important, but they don't mean multiplication. Now with the example down below, we have f. Where's the x? Missing for sake of illustration. Where's the x normally? Right there, and right there, and right there. But some of you don't realize that when there's an x here, an x squared minus 4x plus 7, you don't realize this is really just an empty box waiting to get filled in. Because x just denotes an input, something being put in. X is just like the placeholder for it. So if I put in an x, then yeah, it would go to all the places where the variable belongs. But what if I had -1 instead? -1 replaces every place that x was before. And now all we have to think about is PEMDAS, please excuse my Darren Sally, parentheses, exponents, multiplication, division, addition, subtraction, to simplify. And to simplify, we would start by squaring that negative times a negative to be a positive. We would then, this is multiplication, it's two numbers. -4 times -1 would be plus 4 plus 7, which would be 12. So what's different when I have f of t? No big deal, right? Plug in t instead of x, plug in t instead of x, and plug in t instead of x. But if it's easier visually in your head, think t instead of x. And then we just end up with the exact same equation, just with t's instead. So t squared minus 4t plus 7. No more to simplify because those are not like terms. I'm ones that accidentally think they are. They're very different. Now, when does it actually get hard? Letter C. Letter C it gets hard. As soon as you have a binomial, mistakes happen all the time. So you just have to think of fill in the box. And when I was teaching Algebra 1, why do I keep saying that? Because a lot of these things you've been learning for a long time, but that doesn't mean you're perfect at them because it's so easy to make mistakes. I would actually put an F with a little cow face inside. Super silly, I know. And I would say, what would F of cow be? And they'd be like, cow squared, minus 4 cow plus 7, yay! And they were right. So just replace it with x plus 1. Do not forget to put your parentheses or all craziness breaks loose. How do you simplify? 7, he's easy. -4, no big deal. Him, struggle. Some of you need to work on. I need to foil that puppy. And if you don't foil him, you kill that poor puppy that was supposed to be foiled. Think about it. Then you have to simplify, but hopefully we know what to do. Now pause. I have a whole minute left. Too bad, I have one more page of notes I'm going to still cover. Piecewise function. No. Those of you guys who don't have them, go online tonight. You know where to find it. You are the lazy ones that packed up. Maybe not the lazy ones. The assuming ones. Struggle. Assuming's not always good. Our last part of notes, piecewise function. We've already done him in the graphing calculator handbook. So why do I have a whole other slide here? You're not graphing them, you're using them. How? If I want to plug in different x values to a piecewise, I'm going to go ahead and do it. You guys think about it tonight. Come with questions if you don't get it for homework. You have to look at the pieces and say, which one takes x's of -1? The top piece. Which one takes x's of 0? The bottom piece. And which one takes x of 1? Stay, I dismiss you, not the bell. The bottom piece. You've got to put it in the right piece, or else you can't solve. All right, kiddos, we're done with one point. Homework is done. I'll be here during lunch. I'll be here after school. If you have any questions, please come find me. Otherwise, happy. It's not quite nutrition. Sorry. Finish these notes if you closed up too early.